Welcome to the Bonneville Up to Speed podcast. I'm your host, Kevin Oeste, and this is a podcast covering all things land speed racing on every level, from vintage small displacement motorcycles to cutting-edge streamliners and everything in between. And today, we're honored to have a very special guest from Real Tuners, Mr. Scott Clark. Scott, welcome to the show.
Thank you very much. I appreciate it, man. It's interesting and a good time to be here.
Well, I appreciate you coming on. I know you're a busy guy. So I introed you as the dude from Real Tuners. Is that accurate? Is that what we should say?
That is correct. That's correct. I run a little single-member LLC called Real Tuners, and you check it out at realtuners.com is our website. But it's just a simple calibration or tuning, and in some cases, custom electronics, application or design or testing of custom electronics, almost all centered around motorsports.
So that's a very nice way to understate a lot of the stuff that you do. Because Mr. Clark is a guy who has been around some of the fastest cars in the world and helped calibrate them. I mean, and that's no understatement.
I've been fortunate to be in the right place at the right time. And if I've stuck it out for... Oh man, I mean, I've followed you on social media for like 20 years that I've been doing this. So I mean, yeah, it's 21 or 22 years, I think, was since the oldest video or recording or notes or emails I could find about me doing tuning for someone else was around 21 years ago, I think. Nice. So I've had a chance to be around a lot of cool stuff in that time frame. Maybe it's not, it's pretty normal career, but you stretch it across over 20 years. There's some neat things,
Oh, yeah.
Yeah, so sure, fire away. Questions about any of them. I think I know what we're going to hit on tonight, though.
Well, for sure, because this is the Bonneville Up to Speed cast. But, it's interesting to me today. Technology has gotten so available in all different respects that you can have a career today doing things that you never could have 10 or 15, 20 years ago, just because nothing was available to make it happen. And the tuning and calibration world is definitely one of those.
Man, you nailed it. Yeah, I was going to say the tools that have become available to guys like me have literally just created kind of a niche career for some of us that these things weren't around 15 years ago, even some of it 10 years ago. So yeah, you're right.
Well, and I will say it created a niche career for some of you who know what you're doing. Because, you see it every day. You just because you can buy a guitar doesn't mean you know how to play it. And there's a lot.
But if you spend enough time focused on that guitar, you can learn to play it and probably play it really well. It's your skill level is a combination of how hard you work at it times how smart you work at it. So like anything else, I mean, I specialized in the electronics and tuning because in my circle of local gearheads back in the mid 1990s. I was the computer guy. I was the IT guy. And as soon as people realized that to put a blower on your 4th gen Camaro, you're going to need some kind of standalone EFI if you're really stepping up the power beyond what a factory computer could do at the time, because tuning those was limited too. Well, I got kind of inherited that, but listen, man, I am the last guy on planet Earth that you want to trust to weld 2 pieces of metal together. So I mean, I'm surrounded by people with much more talent. I have way more respect for the chassis guys or the body and paint guys. Their work seems a lot harder to me. So I think part of that is a perspective thing.
Well, for sure. And I know a lot of fabricators who even the sight of a computer keyboard just makes them cringe, so
Sure.
It is something that has a lot of specialties. But I think it's really cool that you started that far back in the early days of digital tuning and have seen the changes and stayed at the forefront, which has allowed you to obviously learn quite a lot, but then get involved with some really, really awesome cars.
Yeah, I'm very fortunate. I think probably the first one that was noteworthy would have been if you watch the very first 1320 videos that Kyle Loftus put out. The Jim Neuenfeld, he went by the username Parish8, and everybody just knew about this twin turbo blue Chevy Silverado 01 pickup truck.
Oh yeah,
it was 4-wheel drive. You could do rolling 4-wheel drive burnouts from 80 miles an hour. Well, that was one of my first. it was probably the 10th or 12th vehicle I'd worked on, but I lived in Omaha, Nebraska, where Jim and Kyle lived, and was lucky enough. Jim said, "Hey, I've got this project that, at the time there was almost nothing for that engine family to be tuned. HP tuners had nothing, and EFI Live had ignition. You could go in and edit ignition tables. So I was very big on the do-it-yourself kit style electronics. The Megasquirt at the time was huge, and which is a very popular system now. But at the time, there were only a couple hundred of us in the country doing it. And I built a Megasquirt for Jim to give him control over the fuel delivery, just the fuel delivery. The rest was Spark with EFI Live. So we had like 3 laptops to run this thing at any given time, because each one talking to a different computer. It was a mess. It was hilarious, but we did really well with that. A lot of Kyle's street racing videos really took off. YouTube was taking off. The timing was right. And we went to Drag Week its first year, and we actually won the small block power adder class with a turbocharged pickup truck running 10 O's.
Oh, yeah.
Hilarious. It's such a ride. That was so slow compared to now.
Well,
yeah.
Relatively.
At the time, it was fast. Yeah. At the time, it was very fast. You could, they won a lot of money with that truck.
For sure.
Street racing.
I remember some of my buddies at Hot Rod were telling me about that truck. And the first time I saw it, I was like, this is insane. And it was so cool because, as you know, when the electronic controls first started coming in and EFI, everybody was afraid that it was going to be the end, and you couldn't mess with these cars. You couldn't tune a new Mustang and all that kind of jazz.
Yeah.
And a little bit of that happens every time you get a new iteration of the operating system, or somebody comes out with a new ECM.
Exactly.
So
yes.
There's kind of.
I'm so glad to be talking to a guy who does this stuff too. Sorry, Kevin, go ahead.
Well,
ask all the right questions. Go ahead.
Right on. Yeah. So there's always a little bit of a race to be the first, to kind of either crack it or today develop the software that communicates with it. And I need to clarify, I'm not necessarily a tuner. I know my way around a few things. I'm fortunate enough to have some people in our shop that are brilliant. But I've been following your stuff forever because what I really like is that you were not afraid to do the Megasquirt side, which is, it's kind of the Heathkit of these things.
Exactly. That's exactly what it is. It's the Heathkit radio of fuel injection, and it scares the crap out of some people.
It's a build your own and with limited instructions. And I remember a long time ago, man, this is scratching different parts of my brain.
You're going back like 15 years probably.
Yeah. So I don't know if you know an NMCA racer named Dan Bills, Dollar Dan Bills.
Yes.
At Finish Line Performance.
Mm-hmm.
And Bills and I were talking easily 15 years ago about taking some factory GM componentry, so an ECM and some coil-on plug stuff, and adapting it to, say, a 1970 Buick 455. Right?
Yes, sir.
And I said, what would that take? And he's like, well, you could physically bolt all this stuff on and put a reluctor wheel on it and figure out the ignition. But tuning, it's going to be a whole different story. So he said, you could do a Megasquirt, but there's no manual. You're going to have to trust people in the forums that have done this before. And I think that's maybe where I came across your name. I didn't do that project, but I was, learning about it. And then it seemed like a blink of an eye later, we have things like, the Holly Sniper and the fast, easy systems and the Phi-Tech deals that, essentially kind of run themselves. So it's neat that you've come up through all that stuff.
Yeah, it's interesting to see those type of systems that come out that are a lot easier for the entry level guy to use over that same time frame, while we were struggling, with learning how to manage, noise from an alternator in delicate electronics and things like that. That's really where the tricks are. So yeah, I was always interested in the Megasquirt stuff because it was cheap. Right?
Yeah,
I'm not
right.
gonna lie. I mean, it was really cool, but then I found out that its reliability was really up to you, and there was a good, solid group of guys that were dead serious about running this on their autocross race cars.
Oh yeah,
different things. And I mean, I felt my way into it and realized that this would work on anything. Like you said, you get a guy like you to bolt everything up, get my injectors in the right place, fuel rails, get me fuel pressure there, get me a reluctor wheel, a cam sensor, and we can do sequential spark and fuel. I guess it's interesting. Really, the Megasquirt stuff is what carried me along. Is if you follow my early history, the stuff I was, known for that was worth looking at, really. A lot of it was, each one of them was a different level of accomplishment with the Megasquirt, up to and including probably the peak of that would have been Engine Masters Challenge.
For sure.
I participated in that for years, and I tuned, Lord, a lot of people don't realize this, but at one point in time, Tony Bischoff had 2 different engines with a Megasquirt that he's quietly using. That was kind of hidden under a lid. But the Sam guys did not. They were Holly guys and fast guys to the core. Who else? Dan Miller, the early Hemi, which was amazing. That engine taught me more about airflow and engine kind of development than any other project I'd worked on. But the Pontiac, the 428 Pontiac that Mark Dahlquist did, every one of these were top 10, in some cases second place and first place finishers, Tony's stuff. But the Megasquirt really lent itself to customization that really was helpful for weird situations like Engine Masters Challenge.
Sure. Well, so that you've touched on the other half of that, and again, today we see a lot of people who know how to use the software, but they don't know very much about the dynamics of an internal combustion engine. So at some point, you have to have a pretty good mastery of what's going on in that combustion chamber and the timing events. So how did you end up picking that stuff up?
So mostly hanging out with Engine Masters guys. Probably the first ones that were really into testing were Gene Adams and Danny Miller. Gene Adams, you'll know him. He was Stu Hilborn's partner forever until he retired here recently. He's 91 years old.
One of the pioneers.
Something like that. Oh, it's amazing. And oh, God. You talk about a guy that can sit and talk some of the coolest stories ever. Don't get me started, but Gene Adams, man, him and Stu Hilborn. There was one year where they installed mechanical fuel injection on like half the field at the Indy 500, all in one test week. Right? People liked his stuff, and then just basically each team came up to him and said, "Okay, put this on our car. Put this on our car." And he's got just hundreds of stories like that. But anyway, a really testing and development with those guys. They would line up 6 different cams for the weekend to test. Man. And Clark just tuned these to the whatever AFR and timing gets the biggest number all the way through the curve. Okay, boom, just go and do it over and over. And then they're playing with injector timing, size of injectors, stuff I didn't think would matter. And it's interesting. We learned all kinds of things. It all culminated in I did 2 way too short years at Blueprint Engines in Kearney. I don't know if you're familiar with them, the Great Motor guys. Can't say enough good about them. Their R&D department, people don't realize. I had a dyno for myself, and I basically 2 straight years just testing whatever they would line up. I had combustion pressure analysis.
Really?
8 channels of combustion pressure, intake and exhaust port pressure. Nothing will open your eyes to how a reciprocating piston engine works more than combustion pressure and port pressures combined, or how you start tuning valve timing events with the camshaft and understanding why you're going what direction you're going. That stuff was the most enlightening thing ever. Honestly, I learned the most with the Blueprint guys. They were actually designing their own cylinder heads and blocks.
That is unbelievable and totally cool. You mentioned the Blueprint guys. We've got 2 of their engines and cars in our shop right now, as a matter of fact.
They run good. People don't realize these guys work so hard at building good engines. It's very impressive.
But I think, again, being able to access the kind of tools, one thing that opened my eyes a long time ago was seeing the first engine on a Spintron. And hearing the noise that the valve train made without any pistons, and I'm like, that's where the exhaust sound is coming from.
It sounds like it's 80% of the engine noise that you hear is the valve train going, isn't it? That's what my impression was first time I was on a Spintron. I was like, well, it's an engine running, but it's got no pistons in it,
right? With no guts.
And it sounds like an engine running. My first time on a Spintron was at Ray Barton's up in Reading, Pennsylvania.
Yeah, awesome.
And they were running Spintrons on super stock altered Hemis, but we had a customer that did a Bonneville engine for one, and they kind of detuned it, made the cam lobes such that it would live a little longer than the 8 or 10 seconds at wide open throttle, and they built an engine for him, and we went production class racing
There we go. So that's the great segue right there, I guess. So
it really is.
The difference between drag racing and land speed racing, especially at Bonneville with the 5-mile course, it's funny because if you're not familiar with it, a lot of people think it's kind of the same, and it's a straight line, and that's about the only thing that's the same.
I just a quick aside, I flew my drone at Bonneville last year, and it was a great course season. So probably a third of the new guys at Bonneville are drag racers who rightfully feel, dude, I'm going 180 in the eighth.
Yep.
I'm going to be going 450 in the mile. Let's get it on. They bring their car out there. But if you look at the picture video from my drone, basically at about the half mile to the 3/4, there's these oil splotches to the left and the right where they had to drive off because they weren't going to make it as far as they thought, because the drag race engine building and tuning is almost a complete 180 from endurance type engine and building and tuning. So it's funny to see. We all feel that way when we get out there, and then, man, does it teach you a hard lesson.
Yeah, absolutely. And to me, that's part of the draw, because there are certain things that that land speed racing has that are kind of exclusive. And what I mean by that is you can't, I don't care if it's a Streamliner or, a motorcycle, if it's built purpose, you can't take this on the street and test and tune every weekend. You can't take it to a drag strip and figure it out. So you've got, a couple of events at El Mirage and maybe some of the Flying Mile stuff, and then the big show at the Salt. And it's like your R&D time is like very theoretical throughout the year until you get there.
Yeah, another fine segue. You can wait 4 or 5 years because of various things, weather conditions, now parts and tire shortages. It may be once you have your car ready to rock and ready to go and you think you're going to go knock it out. I had this happen last year, and the weather conditions, the planets have to align. There's so many things that have to line up. It's way more tedious and frustrating than drag racing. A lot of drag racers couldn't handle that. What do you mean one event per year and it's 40% likely to get rained out?
Yep.
So it's teaching patience, I guess. I move too fast, talk too fast, do things too fast, but it's teaching me a little more patience and just kind of strike when everything is the timing is right. But there can be a long wait, and there's a lot more to it. It's a lot more tedious. Everything about it, I think, is more tedious, and it's also more homespun.
For sure. Yeah. And again, that's another thing that I really like about it is that even though most people on this planet cannot identify with these cars that are competing, they can get there. All it really takes to go be a spectator is to kind of show up. And, there's that old joke where if you stand there long enough, somebody say they're going to put a wrench in your hand and say, give me a hand with this thing because everybody's understaffed and underfunded and there is no giant corporate sponsors and the whole deal. But that should be no deterrent to come out and check it out and help. So let's fast forward to now. It seems like that the past couple of years, the Salt's been getting better in condition-wise. I mean, outside of the isolated rain that's been happening a couple times. But there's some teams out there putting some big numbers up, and I think this is going to be an exciting year.
I mean, right now, they're shaping up to be a battle of the Streamliners, right? That's my understanding. Now, I've been, head down on the science fair project for the last 18 months on this thing, and I can't name the 5 or 6 guys, but Rick Vesco, you talk to him for 11 seconds, and he'll name off, okay, Danny Thompson does this, Poteet does this, blah, blah, blah. They look at Marlo Trite's going to come out with a big number here when they get that thing sorted out. And there's like 5 other guys with liners out there that aerodynamically are capable of doing that number. Are they capable of doing it power-wise? It's really hard to tell. We should talk about that a little bit when you're ready.
Yeah,
about different power plants
for sure. Because they're the ones that you mentioned between Vesco being turbine powered and then piston driven with the Speed Demon guy. It's all different approaches to do the same thing. So yeah, I'm totally into it.
Yeah. So I really. An interesting thing about the Turbine car, the Turbinator 2. Now, this thing was built in the mid-1980s. Okay, so it is it's it's an older design tube car. It's been updated, but it's
seasoned.
It's very seasoned. I didn't realize this. I started off with Vesco tuning a cup car engine in their yellow, smaller Streamliner.
Okay.
I didn't realize that car made its first pass on the salt in the early 50s, 1951.
Yeah.
I think. So the Little Giant, I had no idea till we got out there, and the cup car guys are like, oh, no, man, this thing's like 100 years old. I'm like, okay. I mean, it's been updated too. But anyway, so I started off with them on that project, and then they had some issues with the turbine, with the helicopter engine they were running. The control systems that come with that they're either if they're electronic, they're designed to run it as a stationary engine, pumping natural gas compressors or things like that. Or if they're hydraulic or hydromechanical controls, they're slow responding and they're meant to control these things in a helicopter. Well, they needed a racing engine controller, and they contacted me and said, hey, you worked on the yellow car. Can you take a Holly and make it run this engine? And after looking at how the engine worked for a couple of weeks, I'm like, no, but I could make a Megasquirt style. It's actually a Speeduino, which is a newer do-it-yourself ECU. They call it Speeduino. It's an Australian project. Yeah, and I contacted the guy at Speeduino and said, hey, you actually have some hardware that would work for this. Will you write me some firmware? And Josh Stewart, and he is like all over it, mate. Let's do it. And so he wrote me the code and the firmware. I wrote the design spec and did all the testing and came up with the hardware. So you have to interface this very expensive electronic fuel control valve. And I came up with all the sequences. I mean, it's very challenging to start one of these engines without doing $80,000 worth of damage. So I did that once. And so fortunately, we have a guy, Arizona Turbine, who they donate. I guess they sponsor us with their engines, and they have lots of parts of different things. So if we screw something up, boom, they're on the spot with the parts. No problem. Don't worry about it. Have at it. So they've been an awesome sponsor because those engines are not cheap.
Yeah. Well, I'm gonna slow you down for a sec.
Sure.
Because there's a lot of things to unpack right there. So and by the way, the first time I saw the yellow car, a lot of people think a Streamliner is a Streamliner. It's this thing that looks like a cigar and it's small. When you look at that one, it's like you're looking back in time, especially compared to stuff that's being engineered in a wind tunnel with, FEA analysis and aerodynamics and all the rest of it. And it's so cool to see that old thing out there. It's more, seat of the pants than anything else. And
the Little Giant has broken so many records too, in so many different engine classes, from little flathead 4-cylinder classes on up to, I got to work on that thing. We did a D motor. It was 304 cubic inches, naturally aspirated. Jeff and Keith Dorton built their best D-stroked sleeved cup car engine. That thing made like 770 something on the engine dyno.
Yeah, that's awesome. Those guys
it was crazy. Yeah. And I got to tune that. We went 315 or 317 mile per hour average, I think was what we ended up with on our number.
That is great.
Oh yeah, this was a neat car. It was really neat to be part of that history. And I was, the entire time I was like, man, I hope they ask me to help out with the turbine car.
Well, I remember talking with Dorton at the PRI show a couple years ago, and we were just chatting about the difference between doing those cup car engines and then doing one for the salt. And in his case, it was the opposite of a drag race engine that needs to stay alive for 15 seconds, and his is like, well, mine do 500 miles. I mean, this is only 5.
Funny. He's like, this is the greatest thing ever. He's
easy.
Like, these engines only got to run for like 3.5 minutes. Its whole lifespan.
Yeah,
he told me the same thing. I'm like, wow, okay. He's like, still, but be careful with it.
Well, absolutely, yeah. Okay,
funny.
So moving on to the turbine car. So you mentioned before it's a helicopter engine. So what is this, like a Lycoming, or do we know what it is?
Yeah, so it's out of a Chinook helicopter. They have 2 of these in a Chinook. It's a Lycoming T55.
Okay.
I think it's past hands. Lycoming owns it now. It originally was a Teledyne Continental, or I forget who designed it originally in the 1950s. But it started off as something around 13 or 1400 shaft horsepower. Now the version we have is capable of as much as 5,500 shaft horsepower.
Oh, man.
Yeah. I don't have fuel valve for that. I've got fuel valve for maybe 4,800, 4,700 is what I'm figuring my actual shaft horsepower output can be.
Damn.
And I have validated FAA certified shaft dyno horsepower numbers. It's SAE horsepower.
Yeah.
I was looking at this, 42 days and nights on an engine dyno in a cornfield somewhere in Nebraska.
Wow.
Which is where they test these things, an FAA certified facility that they are federal government, takes these engines and they have Chinook helicopter engines rebuilt.
Sure.
They test them on this gigantic scaled up dyno. So I actually have mapped, I know how much fuel flow in the car is how much shaft horsepower at these elevations and temperatures. So for example, I know that we went on our test pass. We had a very, very fast test pass. We broke the first 3 incrementals that they track out there at the salt course. We stopped, we shut off at the beginning of the 4th mile. But we made, it required about 4,185 horsepower steady to go that fast. And that probably would have been maybe a 508 or 510 mile per hour 5th mile average, we figured. So that's about what it takes for shaft horsepower to be out there, and a lot of people wondered. I had a lot of people ask, hey, did you get fuel flow data? What's your brake-specific fuel consumption? Therefore, how much horsepower did it take? Yeah, it's 4,185 is what it came out to, and the math all works out good.
That is too wild. So the Chinook is the big twin rotor, and it's basically like a transport, like a cargo transport helicopter, right? That's what the Chinook is?
Transport and cargo, yeah.
Yeah, so these are big boys, and I live fairly near to Scott Air Force Base, and every once in a while you'll hear like this otherworldly sound of this paddling in the sky, and a bunch of these Chinooks will go by, giant rotors. Yeah, it's a huge thump. So, to be able to lift, and those things can lift, like the Empire State Building. I mean, it's crazy, the capacity. So
something dumb like 12 or 14,000 pounds or something like that or more.
For sure. So the idea to take that and power a Streamliner, any idea where the genesis of the idea came from?
Don Vesco, no longer with us, but Rick's older brother, I believe. And he was a big motorcycle Streamliner guy that held a bunch of records through this, I think, late 60s on up through. Some of them still stand, I believe. And his brother, somehow, they were always doing things like being commissioned by Wide World of Sports to do some crazy stunts with cars and things like that, or with high-speed cars. Like they had a thing where a skier rode on the back of a Streamliner to test the aerodynamics of a helmet or something weird. Anyway, they were always doing things like that, and they somehow were commissioned to build a turbine powered, taken after the boats, looking at the unlimited hydroplanes that started switching to turbines from big piston engines. I think was the impetus for, hey, let's put a turbo shaft engine in a Streamliner.
And there it was.
And that was early 80s, and thus began the, I don't know if they created a class for turbines. I don't know of what cars we need a Brian Lones or a Brett Kepner in here to see what other turbine cars may have ran. I don't even know which ones there are, if there were any, but there are dedicated turbine engine classes. So he's not, we're not running against Poteet really per se, but we are, obviously everybody wants that first 500 mile an hour certified record.
Yeah. And so the fuel that this thing runs on is what?
Basically kerosene, but it's the Jet A equivalent.
Yep.
I think we probably are just running filtered kerosene would be my guess. It's my understanding is it's not really that much of a difference.
Yeah, you probably could. And that was a great trivia question that my wife's uncle, who was a World War II vet, got me on many, many years ago when he pinned me against the wall and said, the difference between, do you know what jet fuel really is? And I didn't know at the time, I never really thought about it. He's like, well, it's kerosene. It's like, you're kidding me. But it all makes perfect sense.
Cleaner diesel.
That's right. So a kerosene engine, you just said the word cleaner diesel. So diesels respond basically the more fuel you throw at them, the more power they make. And
exactly this exact same theme. Yes,
okay.
Sir.
And that's why
you have limitations. Yeah, so basically the whole control of this engine, once it's lit, the only output, you don't have. It's neat. You don't have spark plugs to fire except to light off the starter. When you fire the starter and you introduce the fuel, you spark it for a little while, spark, then it lights and it takes off, and you turn the spark box off. But there's no timed events. There's no timed ignition. There's no timed injection. It's literally just a valve that basically reads a signal from 0 to 100% fuel delivery. Now, the whole trick is, the driver has a foot pedal. It's just like a drive-by-wire pedal. It's a 0 to 5 volt signal into my controller. It reads that, and the trick is applying that fuel as quickly as you can without damaging the engine or blowing the flame out. And it's very tricky. It depends. if the engine's already at, if it's only at 60% RPM, then you have to bring it on very slow. But if it's at 85% RPM, you can literally just torch it and throw the fuel all the way in it. Mm-hmm. The biggest complaint was the control systems we have so far. If you're in the throttle and you spin the tires and you let off to catch, it takes 7 or 8 seconds to actually reduce the power.
To unwind,
blowing the tires, to unwind it, to unspool. Then you roll back in the throttle, and it might take 20 seconds to get back. So it got to this point where it was an art form to drive. If you broke tires loose or had to let out of it, the run was ruined.
Yeah.
So I came up with a control system that just does that motorsport style. Just make sure it's tuned strictly for torque. Addition or reduction or removal.
Uh-huh.
That's basically the whole theme of that system there. But yes, the only control once you start it is the fuel valve itself, the quantity.
Now, I know the turbine concept in vehicles was very popular in the 60s. We saw there was an Indy turbine car. There was, of course, the Chrysler turbine car that was, a spectacle at the auto shows. Who, believe it or not, they took that on a cross-country run back in '64. And
I saw that. They had a fleet of those things, too. Very interesting cars, some of which still run. My
dad was a police officer outside of Chicago and actually pulled that thing over.
No way, that's awesome. Oh man, what a story.
It's awesome. That's or cool. Not, I don't want to be the guy whose dad was.
No, it is. That's got to be a great story. It's like, these cars you read about in the magazines, I pulled one of those guys over.
Well, and he did because it looked like a flying saucer with those crazy taillights and of course the sound. And so turbine engines, they always talk about the insane RPM that these things spin at. So what are you looking at with yours?
So believe it or not, the RPM is a function of the diameter of the blades, right? So the blades, you still don't want the blades to go past supersonic at the tip.
Okay.
So ironically enough, my big Chinook helicopter engine spins a whopping like 13,000 RPM. It's really not that much because it has such a big diameter compressor blades or fan blades that it you can't spin it too much faster. So you try to make that up with volume of air.
Okay.
But now those little tiny turbines might spin 60,000 RPMs, the one with a little 4-inch diameter.
Yeah, those things are winging.
That's why the little ones in the cars and the Chrysler cars were crazy screamers. But this one, it actually doesn't have the shaft RPM that everybody thought. I didn't realize that either.
Huh.
But yeah.
All right, so take me through how we are spinning 13,000 RPM of kerosene burning madness into moving some wheels.
I'm glad you asked because, it's not thrust, all right? I want to reiterate that. It doesn't have a jet thrust pushing like a jet airplane. There's literally no forward thrust from exhaust. Well, how it works is there's two parts to this engine. There's two crankshafts in this engine. And it's really one beer keg in front of another beer keg is what it looks like in general, description. Mm-hmm. But the front engine is a regular jet engine that has a thrust or exhaust coming out the back of it with a crankshaft that spins. That's the higher speed. That's called N1, the N1 crankshaft and the N1 speed. We have to watch that. Can't let it get over speed. And we have to watch it not get too slow speed on startup, things like that. But so N1 does the combustion, puts the fuel in, lights it, gets it hot, sends it out the back as a stream of hot exhaust, which then instead of blowing out the back of the car, it blows into a tube that directs all that hot exhaust into a power turbine. Okay, much like the hot side of a turbocharger in a turbocharged drag race car. Only it points straight into it and bleeds off all that heat and energy into spinning that shaft. Okay, that's N2. So we have to watch its RPM too, and we have to be careful with it, because if we break anything in the drivetrain downstream of N2 and it takes off like a slingshot, 20,000 RPM or whatever,
then you got pieces all over the place.
Parts scatter to break the car in half. So
wow,
got to be really careful about that and shut her down as soon as you detect an overspin on N2. Well, anyway, so out the back of N2 is a shaft, a PTO shaft. It is spinning a max of 18,000 RPM. Mm-hmm. Okay, and we have a gear drive deal that's a 1 to 2 or 2 to 1 reduction. So we spin that down to where its maximum RPM is about 9,000, or about the same as a healthy piston engine.
Mm-hmm. Mm-hmm.
That's how that works. Then, believe it or not, it's a Gilmer belt drive off of that. There's no transmission whatsoever. There's a Gilmer belt drive.
Oh, wow.
On a pulley, like a blower, like a top fuel blower belt, that goes over to a shaft, that's going longitudinally down the long axis of the car to the left side of the driver, and that goes all the way to the very front and then to the very rear, where again Gilmer belts on each end hook to effectively a belt drive on the front of a regular differential. Okay, like I don't think it's a winner's quick change, but I do believe it's a 9-inch base diff,
okay,
front and rear. Okay, so we don't have any clutch. We do have brakes, and obviously it's all-wheel drive. But the way the system works is you can just stand on the brakes, start the engine, and it's trying to take off like a car in gear with a tight converter, but you can hold it with the brakes. Let off the brakes, it slowly starts rolling. You bring on the throttle, and it starts to spool up, starts to spin things, and you take off.
Oh, man, that is crazy. So
isn't that nuts?
As N2 starts to spool up, that's where all the motion comes from.
Exactly. N2 is tied to your ground speed or your wheel speed. So and it's got these behaviors. I'm a drag racing guy, and one of the things I was really excited to see, I talked to our data guy, Ron, who was the original founder of RacePack. The data shows that it's like a torque converter, only it's like a hot air torque converter. We actually get a coupling effect once the N2 speed gets up to 300 miles an hour or so, N1 kind of starts to tie itself to N2, and they couple together, and you get to this thing where it's almost like not having a torque converter, or like the converter is locked, and you can really pour on the steam and the water injection.
So that was my next question is, so you're obviously measuring the crank speed of N1 and N2, and there sounds like there's a point where they almost go 1-to-1, and you said it's like at the 300 mile an hour range?
Correct. 3 to 350. They at least seem to start to couple. I need to look at their actual RPM numbers. We look at those numbers in percent speed, right?
Okay.
Which is a weird thing for me, but the actual RPMs are approaching coupling. They're showing this behavior where, like at the start line, you can just floor it, and N1 will just zip up and wind up to whatever you want it to, while it melts off the turbine on the N2.
Right.
But so you have to be careful there. But once again, I noticed around 300, 320, 330 miles an hour, we could be into the fuel, and it was almost like they were coupled. You really applied torque, and it was literally spinning the tires at 390 miles per hour.
Yeah,
when you rolled into it too aggressively. And all four.
Yeah, so it's all-wheel drive with the same ratio, front and back.
Mm-hmm.
Yeah, and
yes.
All right, so my mind is just trying to visualize all this stuff. This is wild. As this thing is spooling up, so you said that N2 eventually equates to like a 9,000 RPM piston engine. So that would be at your max velocity on the salt. So it's got
Correct.
Obviously an RPM range.
Yeah, we're geared to top that out somewhere around 540, I think, 545. With our tire slip, I think we figured.
Wow.
So good year, 5-6%. Typical year, 8-9% tire slip.
Okay. Wow. So these are not very many parts that you're going to find at your local corner parts store, especially the engine management system. So how did you adapt? I'm guessing a piston designed engine management system to run this thing.
So it's real interesting. I started off with I knew I had to do something do it yourself. The Speeduino guys had a little bit cleaner and more accessible software and hardware, and they would let you run their software on your own hardware design. Is probably the neatest thing about that. It's a if you're into the Arduino, it's a do-it-yourself community. These guys are big on making really fancy Christmas light controllers for your. If the guy in your neighborhood's got like the craziest Christmas display lights, he's probably doing Arduino or Raspberry Pi or one of those do-it-yourself electronic systems. Well, you can run an engine with Arduino, and I approached these guys, and Josh was absolutely on board. Now, the actual differences, not much. So we have to read RPM, but we have to read 2 RPM inputs. But that's where you start. But that's too simple. It's the same. It's called a VR sensor. It's the same thing you find on Ford Modulars and Coyotes for the crank sensor. It's a 2-wire. Picks up reads a tooth reluctor. There's 17 teeth on each of the crankshafts. And so we read those, right? So you're N1 and you're N2. The most critical input, I think, the most critical inputs, number 1 is the driver's foot pedal, but that's just a 0 to 5 volts, just like a TPS sensor hooked up to his pedal, right? So we're still all in the same. If you break this system down by its inputs and outputs, there is a matching piece of hardware in every ECU out there. So your inputs are the throttle pedal and a switch that says, hey, just turn the power on, hey, run the start sequence, that kind of stuff. But the outputs is simply it's a PWM output. It's the same thing you would drive a Mack solenoid valve or a turbo boost control valve with. Okay, that's literally the fuel valve reads this PWM output, reads as an input, and it knows, hey, 100% duty cycle is all the fuel I can throw at this thing, and 0% is no fuel. And it's a linear difference between those. So very simple, really. It's not that bad. And now the only thing left, I'll be quick, but the fuel table, instead of having manifold pressure going in your Y or up and down axis and RPM going across, I have throttle position. So basically it's alpha N. I have throttle position going up and down vertically in the fuel maps, and going horizontally is what we call compressor discharge pressure, CDP. In other words, how much boost the engine's making. Okay. And so you can say at any given point, hey, if I'm at 3/4 of the way up in my allowed CDP, then I can just pour the fuel on like crazy. But if I'm coming off idle, I need to ramp it in slowly over 4 or 5 seconds.
Sure.
But that's the only difference.
So what I'm gathering is you ventured into a world of maybe those pressures and throttle inputs and the fuel consumption were unknown numbers, I mean, you probably knew the concept, but you had to do this to kind of figure out what it was doing. Yeah. So once you got once you got that down, but you didn't need to monitor an ignition curve, so it's almost simpler.
Correct. It is simpler. There's some things that they are give-me's that are making it easier on you, and some things that are a little more challenging. But it was actually surprisingly easy to do once we figured out what we needed to do. But let me back up. There wasn't too much guessing because Lycoming publishes, hey, for a given altitude, they basically would give you the fuel demand and the ramp curves that they felt were safe, what they would run in the helicopters versus what you could get away with on a stationary engine or in a boat. These are, navies, the Swedish Navy runs these engines in some of their interceptor patrol type boats. So there's a lot of different applications, but they had data that the guys at the dyno shop at Nebraska Gas Turbine were kind of there. They were super excited about this, and they were providing me, hey, we'll get you any 1950s data on this engine, how much fuel you can roll in and what rate. And we started with that. We started with that program, and I digitized that, okay, and put that in my tune. And then we started turning things up. Well, what if we can ramp this thing up quicker? We ended up getting to the point where we could go from idle to full torque in just over 4 seconds.
Oh, man.
That was pretty cool. Yeah, I mean, it twists the ground at the dyno shop. It's,
for sure.
Not advised, but to go from 300 foot-pounds to 3,000 in 4 seconds is pretty cool.
That's serious. Yeah.
But anyway, I got a lot of help from those guys. In fact, one of the guys at the dyno shop was one of the tuners for the Miss Budweiser boats in the 80s.
Oh, really?
The unlimited hydros that ran these engines as well. And I had some real solid dudes looking over my shoulder helping out for sure. I'd have been completely lost without those guys.
Well, that's really cool that they helped you out. And by the same token, again, there's probably not that many people around that have that experience, so they probably know what's going on, finger on the pulse kind of thing, and heard that this was going to happen.
They do. And they always wanted a motorsport style ECU where they could tune that kind of stuff, right? So I was like, hey, I'll build it. You can tell me what to put in it. And they're like, well, I'll tell you how to run it and how much fuel it wants. You figure some kind of control out that lets us adjust that. And so we put our heads together and we came out with something pretty cool. Now all the tractor puller guys want it.
Nice.
All 20 of them. But
well, still, hey, that's great.
Yeah, no, it is. It's cool. Yeah. It's actually going to see this on some other stuff out there, I think, in the next 2 years.
That is outstanding. I love to see this stuff grow in every possible direction because it's only good for all of us.
Right.
Now, in the original installation, well, I guess let's just go back to the Chinook installation. Do they rely on that N1, N2 concept as well to spin the rotors, or how does that work?
They do. Okay. They do. N2 is hooked directly to the gearbox that is hooked to the main rotors. The main rotors on both ends, right? So that's absolutely how it works the same way. The N2 in our case is hooked to the drivetrain, and in their case it's hooked to the transmission that runs up to the gear reduction to the rotors. Blades. And I think they run like 350 RPM. Says how much they gear it down. So there's a lot of gearing down going on there.
Oh, for sure. Yeah. Well, again, that being such a big rotor, you don't need that thing going that fast.
No.
Wow. So in the current form, how long has the Turbinator 2 been together?
I want to say this iteration probably they did a lot of rework to it, and man, I wish I had Rick on the phone to like answer for sure. But sometime in the early 2000s, maybe the 2004, 5, 6 era, I think is where this one kind of materialized, and they've really just been doing fine tuning and development. And learning on this iteration, and this is kind of the final. I mean, we've basically been told, look, you do that 500 number, this car is going to get hung up in the Smithsonian, or something similar to that. I mean, they're not. Right. We're going to park it when we hit that number. So we're being gentle with her.
So outside of the challenge of driving this thing and giving that proper amount of torque at the right time and minimizing that wheel speed, slip, and also keeping it going straight down the track, what are the other big challenges right now? Tires for sure. Yeah. I mean, in fact, there's been a big, this test pass that we did last October, we were going to run the big number, and we thought we were prepared, and we got the car out, and we realized that the archaic parachute control systems and safety systems, man, there was just too much opportunity for a human error before you let the guy off the line on that system, and we had to completely rework it. But following the old archaic design, I mean, it had something like 35 automotive relays. Okay, there are actuators that work on 24 volts, 16 volts, 12 volts, and 5 volt sensors. Okay, wow. So you have power supplies and systems in the entire car, in some cases separate front and rear because they're 36 feet away from each other. So there was a lot going on, and it got to be a last minute deal. And I literally put out a Hail Mary, help me help on on Facebook. And three of my students from my EFI tuning classes responded, hopped in the car and headed out to Utah. I'm like, listen, I need some wiring guys. I need some competent fab dudes. We have to get this stuff sorted out. Well, my three friends, Cody, Breacher, Jeff Holtz, CJ Durbin, they came out from Quad Cities area and spent a week getting the car ready, and then a week on the salt troubleshooting things. And long story short, we only got time to make one pass, and we really needed to test the chutes and everything. So we made our test pass. The good news is we blasted. I mean, we went. What was long story short, we went 397. We went almost 400 miles an hour at the 2 1/4. Oh,
right. That's the first time point. Yeah. I mean, that's pretty much 100 mile an hour faster than anybody else is going. But so we, I say that there's a couple of really fast guys out there that have been close, but that ours was the fastest number. And we proceeded to set the next two incrementals. After that, through the three, we would set all-time world records on the salt for wheel-driven cars, but we had to get those chutes tested. Well, during that test, it showed that our tires suffered a little more stress than we'd like to see, and so they were having to recommission new tire manufacturer this year. I think didn't Goodyear purchase Mickey or something, or their tire operation, something like that?
Yeah, that's what happened.
So it was actually a good thing for them, because the new owners came in and said, "Hey man, let us make you a tire, but let us get you some fresh ones for this 500 mile an hour."
Right on. Yeah, good.
Yeah. So it worked out very good like that. But I mean, we have a guy somewhere up in like Montana or somewhere middle of nowhere that spins these tires for us, test spins the wheel and tire combo and balances them for us, to 600 miles an hour. It's not cheap and not simple task. The wheels are made by Greg Peak, American Track Roadsters in Denver, Colorado. Just brilliant design and machinist. Just absolutely essential. Vesco was all volunteer. I don't know if you knew that.
Yeah,
literally all of us. None of us are getting paid.
Awesome.
Yeah, awesome. It's been a while since I've done volunteer projects, but man, this is a good one to do it on.
Well, for sure. You guys are doing stuff that, again, it's not just setting records. I mean, it's definitely pioneering a whole new thing.
To be the first 500 mile an hour record at Bonneville wheel driven, to me, that's almost hang up your hat, stop trying to do cool things, or, that's going to be the coolest thing I'll have done. So I'm going to work really hard on that until I'm either dead or we get it.
Well, and to clarify, so this car has gone 503, right? But it wasn't a record. It wasn't backed up.
Correct. It was an exit speed. Our actual record in our average in the mile. Maybe back up for the listeners here.
Yeah, explain that.
So Bonneville records are based on your average speed over the course of a mile, which sucks because you have to hold that speed minimum, the whole time.
For sure.
So first off, someone's got to start. That average mile has to be 500. If you entered the mile at 490, you better exit it at 510.
Yep.
Right. Well, I think their average was like 491 or 490 or something, but they were still accelerating very fast. And at the end, their trap speed, they left the course. They gave you just hey, what speed were you going at the end of the course, at the end of the 5th mile? And it was 503, and it was the first ticket at Bonneville that was ever printed with a 5 anything.
Wow.
In the modern days, there were guys back in the days that ran thrust cars there briefly. I don't know if those were actually competing. I think they were doing FIA type records or something. I'm not sure, but Bonneville is about wheel driven cars these days, and so for wheel driven cars to see a 500 mile an hour anything, a lot of people, probably 30, 40 years ago said it could be done.
Well, yeah. So I don't think there's even a class anymore for a thrust powered vehicle.
No, they don't allow them to run out there. Not enough space.
Yeah, especially for the speeds they were going, in the 70s. So then. At the same time, I know I picked up on this a little bit earlier when you clarified that this is not a thrust-driven vehicle, because it sounds like one.
Right. It does. It's funny. I get a hard time from a lot of my friends. Oh, well, it's a turbine. Duh, it's easy.
Yeah,
right. Let me show you this picture of this thing on the dyno with 700 different circuits coming off of it and 35 different fluids and pressure, sensors. And it's very complex.
Yeah. Well, it's so easy. Let's see how many other people have done it.
Yeah, I've been contacted already with another Streamliner team that wants to do it with twin piston engines, and they're very keen to know about our data, how much shaft horsepower, how horsepower did it take, what's your frontal area, things like that. Well, they already know that. Vesco's are real sharing about that kind of stuff. But there's another team that wants to try and do it with piston engines that I'll probably be working with here in the next couple of years as that car gets ready to go. But for now, I think the Turbine is probably going to be the first car to do it, the Turbinator. I certainly hope it will. And obviously, I hope that everything goes well and safe. But what we have to do is we have to average 500 miles per hour for 1 mile, okay? Then we have to turn the car around with no more than 3 hours of maintenance and basic service and do it again the next morning. And if we can do it twice in a row, we get the record.
There you go. So as we are recording this, it's the end of April, and Speed Week is in August, and then the World Finals after. So what's happening in the program like today?
So just 2 weeks ago, the 3 guys that bailed us out, went out there to rewire the entire systems, the safety systems in the car. We went ahead and custom built, much like the custom ECU we built last year to control the engine. This year we built 2 more controllers that go at the front and back of the car that talk over CAN bus. They're based on Arduino, and they handle the safety systems, right? So when the driver pulls one of the chute buttons or hits the emergency stop, depending on the speed you're going, the GPS speed or your tilt angle, or the G-force shock, it'll issue commands to the rear controller to, hey, shut down the engine, open the parachute clamshell doors first. Okay, there's a pair of clamshell doors that have to be opened. You gotta wait till they're open before you fire the chutes, or you will foul the chutes and they won't work. So there's a complex system where you open the chutes, you fire a relay. Okay, you trigger a relay. It's the same thing as a cooling fan relay or water pump, right? In a regular car, you fire that. You look for the doors to be open. There's position sensors. Okay, once you know they're open far enough, now you can start the sequence of launching the 3 different parachutes, and you got to get those right because you can't launch the low speed chute at 530 miles an hour. So you got to get the high speed chute, the medium speed, and then finally the low speed chute to get the car slowed down. So we built that system over this winter, tested it here, and my one employee, Jason Shackelford, and he helps me on the design and the hardware. We tested those here, and then Cody, Jeff, and CJ went out with their wives, and the wives took a vacation for a long weekend, and these guys wired up the car, and they removed. I made a Facebook post. It was like 24 automotive relays they removed. We're down to having 6 total in the car, I think. Very simplified system just by using CAN bus.
Right.
But we built our own CAN bus communications between 2 controls, basically.
That's really cool. So where does the car live?
It lives in Rockville, Utah, southwest Utah, just a couple hours from Las Vegas.
Okay, gotcha.
Northeast of Vegas.
All right, so that 3-stage chute concept, so these are also utilizing speed sensors to time the triggering. Is that the same speed sensor the ECM is using, or the? So
I've got a GPS module on the CAN bus network, actually physically in the hardware of one of the systems in the car.
Okay.
So it knows the GPS speed at all times, right? So it makes decisions like, hey man, I'm not going to launch the chutes accidentally if I'm not going 30 miles an hour or better, right? Because they've had a scenario where the chutes fired and launched 10 feet out. It was very embarrassing. So the rule number 1 was not ever having that crap again. Right? Clark, if you do anything, you make sure that this never ever happens.
But those kind of things are part of racing.
They do. You know, it's embarrassing, and these guys have a long history of being real good on the salt. I'm like, listen, you're gonna get caught with your pants down every now and then by accident. You just got to kind of. It defines your character. But anyway, we watch the speeds. We watch it. There's a modern tilt meter, a gyroscope. It's an IMU, inertia management unit. It's the same thing that's in like a Davis VPS traction control or vehicle position sensing. Modern ECUs, motorcycles have them. So I'm using this to detect if it tips over, what speed it's going. And we apply that to the logic, right? So if he pulls one of the chute buttons, the first thing that happens is, hey, driver, pull the chute button. First thing you got to do is check. You got to pass the message to the rear controller, okay? Then you got to check that the doors are, the doors aren't open yet. This is the first chute being pulled on this pass. Open the doors, wait for the signal to open the doors, or a timeout function in case those sensors were to fail. We'll wait as long as 0.4 seconds for the doors to open, then launch number 1 chute. Yeah, it's an eternity. We figured this out from the time the button is detected to the time that the actuator happens. It's about 10 inches of forward travel at 540 miles per hour. Oh, man. So it's pretty quick. It is. The guys wanted to know. They're like, well, how at 540 miles an hour, I want to see this in distances. How quickly is this working?
Well, yeah.
And we actually mathed it out with the Vescos and with Dave Spangler, and they were satisfied. It's been passing the tests in the shop. So that's what we did most recently is cleaned up the safety systems.
Okay, so a couple more quick questions about this. It's interesting that you said you were able to equate the clock time versus distance, because you've got to keep in mind, if you're waiting for this car to slow down before you can throw the next chute, there's a driver who could be in peril. So, this has to happen at the right time with all that going on. The other thought is, what is the what does the SCTA say? What's the rule book on these type of systems?
So you have to have a mechanical system as your primary chute launch system. So there's this very, very reliably working but Rube Goldberg mechanism that takes a pretty strong arm. It's almost like a ratchet shifter. Well, it's almost like a motorcycle shifting, but you push this lever. First push is the doors and the first chute. The second push is the second chute, and the third push is the third chute. So he's got a mechanical way of doing it, and that's all they actually test and care about in tech, right, is the mechanical system. So it gets a thorough check by those guys.
Yeah.
But the electrical is the convenient one. Driver doesn't want to let his hand off the wheel at 530, 540 miles an hour that we're going to need to exit at. So
sure.
he'd rather just tap a little button under his thumb that's already there and know that's going to work. So we focus on the secondary, but used primarily electrical version. And the mechanical version is handled by the mechanical guys on the team, a whole different crew.
Interesting. Mm-hmm. Well, very, very cool. Listen, this has been a huge education, Scott. I really appreciate you taking the time and sharing these stories. And I'm looking forward to seeing it in person. And we'll see if you're able to knock down 500 on a record. That would be really awesome to see.
Yeah. Make sure you or any listeners that are out there come check out the Team Vesco pits. Man, they're equipped. They're used to having a big crowd, so it's you can get right up close and personal with the cars and check out what I'm talking about. Come say hi, you too, Kevin. Come see us, man. We'll roll out the red carpet and give you the tour and come hang out while we go make passes. Well,
and you're not kidding. I've been to those pits before, and everybody is super, super nice, and they might be intently focused on something in the moment, but the other thing that's crazy about especially Speed Week is it's the slowest, fastest thing in the world.
That's great. That is the best way to describe it. It's either that or camping on the moon with your hot rod.
Yeah, right, exactly.
It's about the same thing. Yeah, it's just weird, slow, fast, interesting, very cool spectating.
So you mentioned earlier the real tuners and that you do offer EFI education. Where can somebody learn more about that?
When I can, I do. Check out our website, realtuners.com. I mean, I have some online webinars that we gave that are real popular for if you're new to Holly, EFI tuning, for example. We've got some webinars there you can watch. I actually put on live classes. This year, I'm going to try to do 4 classes. I'm getting ready to do my next one. It's at 417 Motorsports in Springfield, Missouri, with Blake Hughes. If you're into drag racing, you know those guys. Mm-hmm. That's May 21st and 22nd. Already sold out. But we're looking at lining up a Dallas-Fort Worth class here in the next, probably 3 or 4 weeks. We'll have it listed, and sometime in the next, it'll probably be a June, July kind of thing.
That's cool.
Yeah. So we're trying to do more of those again. We used to do them 2 a month, but the COVID stuff really slowed down the live classes.
Yeah.
So we're kind of just emerging from that.
You could you could take a class from somebody who's a salesman at a non-brick and mortar website, or you can take a class from a guy who's knocking on 500 miles an hour and has this kind of experience. So, there's my little nod.
It helps the marketing. Right?
That's right.
I feel like I'd like to see people that teach classes that have experience that's good. It's like, wow, this guy's done a couple of things. I'd rather see a guy like that struggle through public speaking than I'd like to see the real polished class.
Who doesn't know anything. Yeah.
Well, I don't want to say they don't know anything. A lot of them are great. A lot of them good theory stuff. A lot of them out there. But, I'm a practical hands-on guy. My classes are all about how to use the tools, mm-hmm. kind of somewhat regardless or with no real concern for which tool you're using. So
you got to have the concept down before you can do it.
Yeah. So it's kind of basic in some ways, but guys, we get good feedback. So I enjoy doing the classes.
Well, right on. I'm sure there's a lot to learn. So, Scott, I really appreciate you joining us. I hope you enjoyed your time. This was a lot of fun. Like I said, very eye-opening on the technology and the strategy. And I
appreciate your interest in the tech, man. But very few people or places I go to talk about this stuff. You start talking about engine controllers and they just glaze it over, But Kevin, man, he's done this stuff. He knows how it works. That's good.
Well, I appreciate that too. This stuff's always been fascinating to me, and the land speed thing was something I always loved. Reading about it in Hot Rod Magazine, the whole thing, and never really had the opportunity to get involved. And recently, I was speaking with some friends of the SCTA and Ron Main. and it kind of dawned on me that I'm not a racer. I don't have a land speed car. I'm not a driver to that extent. So, but I want to help. I want to do something to help promote this. So what do? Well, I can BS with people and hopefully get some stories. So I'm doing what I can.
So are you going to go around and talk to different guys from each of the Streamliner teams? I mean, there's probably 4 or 5 of them that any one of those other guys could pop off the 500 number accidentally.
Well, for sure. And I do want to clarify that this podcast is not purely about Streamliners and the fastest speeds ever attained, because the sport goes all the way down to, people that are running less than 100 miles an hour. It's all about coming together and putting a machine together and making it happen. But this year, you're right. I think the stars are lining up to make a really cool year.
I think it's a big Streamliner year. I think it's going to, and I don't know what the weather's going to do. We'll get out there and get a crappy course, and everybody does mediocre, right?
Don't say it.
Course. I know. I don't want to jinx anybody. It's looking great. Come on out. But,
all right.
Yeah. So anyway, I appreciate you having me on. It's good to talk to you and finally be on your podcast, which is really cool. We enjoy listening to it here at home.
Well, thank you. Yeah. And I appreciate you joining us. So Bonneville Up to Speed is produced with the blessing of the SCTA, the Southern California Timing Association, and is available on all the major podcast platforms. Subscribe if you're into land speed racing. Check out our Bonneville Up to Speed Facebook page, and be sure to visit scta-bni.org for all the latest news and the calendar of SCTA racing events at El Mirage and the Bonneville Salt Flats. Thanks for tuning in. And for Mr. Scott Clark, I'm Kevin Oeste, and now you are up to speed.